Hi guys, I'm going to be talking about classes of needs satisfied by the control system. There are three major reasons why you need the control system: to suppress the influence of disturbance, to ensure stability of the system, and to optimize performance. In this particular video, I'm going to be focusing on how to suppress the influence of the external disturbance on a particular system. Now, let's consider a particular reactor. If I have my feed coming into this tank at a flow rate of F1 and at a temperature of T1. Now this is the tank. Now I need to heat whatever it is that is coming into this thing in order to get an output. Now whatever is coming out must be flowing out at a flow rate of F and temperature of T. You will notice that the temperature has changed. Now to heat up this, I'll need steam to heat it up. Okay, so now there is a boiler here, so I have steam coming in through this valve. Steam is coming in through this valve, so steam is S. Now when steam comes into this valve, any steam that is here will heat up your content inside the tank. Let's say for example our content is water, so steam will heat it up. Now this particular boiling mechanism here is like as if you're having a tube, a coily tube. Okay, this is how it looks like. I'm trying to give you a very graphic image. If you have a boiling tube, now as the steam enters this boiling tube and passes through, I told you it will be heating up the water here, and at the same time as it's heating it up, that's exchange of heat. This one will condense, so as it's condensing it comes out as water here. So here I have the condensate, let me call it cond. Okay, now what happens is that inside this tube, as the hot steam at very high temperature flows through, it transfers heat into this tank. After transferring heat into this tank, then it becomes liquid, okay, and comes out as the condensate. Meanwhile, on the other hand, you have your output coming out at temperature of T. Now we're told that is a well mixed, I'm assuming that is a well mixed reactor, so that shows that you need a mixer here. Okay, now you have every single thing you need here. Now this is a standard system, this is the way to be. You have a temperature coming in, now this steam will heat it up and you have your output at temperature of T. This is a standard example. Now because it is well mixed, that's because of the fact that it is continuously being mixed, so any value of temperature that you have inside the tank is the same that will be coming out, because it is uniform all around and is a continuous mixing process. Okay, so any value of temperature I have here is the same value of temperature that will be coming out of this tank. Now let's take an example. If for example now this was coming in at 30 degrees Celsius, okay, and I have hot steam at 400 degrees Celsius, okay, and this is coming out at 120. Now there's continuous mixing here, so if this one here is 120, whatever it is that will be coming out here will be 120. Now assume a situation whereby your feed temperature is changing. I pour in water. Let's assume that initially I poured in water at 30 degrees Celsius. The second time I now pour in water at, let's say, 50 degrees Celsius. The third time I pour in water at 60 degrees Celsius. That means I'm saying my F1 T1 is changing continuously. Now this one, if what is entering continues entering at 30 degrees Celsius, the whole process will be repeating itself if this 30 degrees Celsius doesn't change. But in a situation whereby you're having different temperature, that's entering at 30, entering at 40, entering at 50, different temperature, obviously your output will not be constant like you expect it to be. Now that's where a control system comes in. You notice that this, look at what we said here: suppress influence of disturbance. Disturbance means input. That means this input has been changed, so we want to suppress the influence of the change in this input. So what happens? We still have our steam coming in here. Okay, I still have my steam coming in through this boiler, and I have it coming out as a condensate, cond. Same thing is still happening. I have my steam here, S. Okay, this is the valve through which the steam will pass through. Then I have, in this case, what will now happen is that there will be a measuring device. The measuring device in this case is called thermocouple. So the thermocouple, I'm going to call it TC. The thermocouple will measure the temperature. Now do not forget, I want to achieve 120 degrees Celsius here, and because it's a well mixed reactor, continuous tiered tank, so is continuously being mixed. Whatever it is that is inside there is what will be coming out. Okay, so that means if I want to measure what is coming out here, I can just decide to measure what is inside here, since it's the same thing. Okay, so this thermocouple will measure the temperature inside this place. It will now send it, this thermocouple not controller, it will now send it into the controller. Now before it gets to the controller, it will send it to the signal point. In the earlier video I explained, I said signal point is where two or more things meet each other, two or more wires, two or more units, two or more processes is called signal point. So this is the set point. So the set point will give the signal point the temperature. Set P, this set point, it will give this signal point the temperature, that's TS. Meanwhile, the thermocouple would have already measured the temperature of this place, so it will send it to the controller. So these two things are going to enter the controller. Okay, so this is the controller.